essentially is containerization and orchestration. Okay, just for the recording purposes. Yeah, so this is probably an image that you would have seen usually when you search for Docker. So the idea of Docker is, like, to simply put it, it's a tiny VM, but it couldn't be more forced than that. So the idea is everywhere we're going to have a hardware level, like your hardware, of course, your host kernel, then host file system. Then in the case of virtual machines, you have a second kernel level. And in containers, you don't have that. So how this manages to do this piece is inside containers, instead of having an extra kernel, what you do is use the host kernel, but isolate a small section for the specific container. So that in that way, you can have a separate sort of kernel for that specific container. So the way we do this is using things called C groups and namespaces. It's fancy terms, but nothing much in there. So C groups essentially lets you limit what resources, as in limit how much of a resource can this pod or a container, your Docker container can use. By the way, if someone has questions or if I'm rushing, feel free to ask me. Yeah, and you have a lot of C group types.
A little bit of context, right? One reason why I thought of opening this one out was talking about this is most of our deep learning models deployment and everything actually happens to Docker and Kubernetes. Helps with scaling. We all worry about training aspects of it and stuff like that. But when you actually put it into production, there's a lot more aspects that we need to worry about, right? And this is our tech stack that we actually use for operationalizing. That's the reason.
Yeah. So C groups, it's a specific method that or a way that the Linux kernel provides you to isolate stuff or like limit stuff in the specific case. So for there are a lot of C groups. The main ones are CPU. This one lets you schedule CPU cycles for the container, and CPU set. It's a another one wherein if you have a multi-core system, you can just give one core to the container. And memory, same for restricting the usage of like memory usage, external device access, and this is for external IO stuff. And the same way you have namespaces, which are used to restrict access. C groups limit how much you can use. This restricts if you can use it or not, or like gives you an isolated environment for you to use. So again, namespaces, mount is for file system. So let's say when you're using an Ubuntu Docker container, when you spin that up, what happens is you have an Ubuntu file system set up somewhere in your host machine, and you restrict your containers view into just that file system, which is inside a folder. That's what happens. And PID is for process IDs. So you can, so if you check the process ID of your app or something that runs inside the container, it's always going to be one. Why this happens is because it creates a separate PID group so that it runs in that PID. And net isolation for network access and stuff. IPC, interprocess communication, again, kind of along the lines of PID. So your process inside the container cannot communicate to a process outside the container. Essentially isolating stuff, that's all it's about. UTS, it's about giving a separate host name. The name, like why it's named UTS, it's kind of funny because like when the idea of namespaces first came up, you just had UTS, and that was for Unix, and so they just gave it Unix time sharing system and not like host name namespace or something like that. So yeah, and user, you get separate user. That's it essentially. And yeah, of course, Docker is a lot more than this. They add a lot of much nicer networking features so that you don't have to mess around with a lot of configs to actually get into the container if you want to do that and stuff like that. Yeah, and okay, yeah, cool. That's something about Docker. Let's assume, okay, let's pretend you got Docker. And okay, you have your app, you put that inside Docker, it's blissful. And how do you deploy these things? And that's when Kubernetes comes in. So a few reasons why you want to go for Kubernetes is, you'll probably understand this towards the end, show you a demo, but one idea is it's easier to allocate resources for your specific app using Kubernetes. So think of Kubernetes as something that manages a lot of VM instances. And when you want to deploy something, you say to Kubernetes that I have this app, which deploys this for me. You don't have to check which instance has like RAM or CPU free and then allocate it to that instance and stuff like that. Kubernetes automatically handles that stuff. Yeah, and if you want to deploy a newer version, so let's say you have an app deployed, v1.0, it works, it's awesome. And if you want to deploy v2.0, it actually does a rolling update. So it spins up v2.0 and then reroutes your traffic to v2.0 and then kills it and replaces it. It just works smoothly. Stuff like that, Kubernetes takes care of. And yeah, automatic monitoring and restarts and stuff. So let's say your model, it goes happens. Kubernetes will automatically restart it, so nothing goes down essentially. So like let's say you have 3 copies, one goes down, the traffic gets rerouted to these 2, and by the time these were serving for traffic, another one can be created and inserted here, and you again have 3. Yeah, and scaling, it's really easier. I'll show you a demo. You'll see how difference that makes. Yeah. Okay. So why Kubernetes? I'll give you a simple example of why you would want to use Kubernetes and Docker. So you have you wrote an app, it's awesome. You get started, and you go to GCP, get an instance, GCP, AWS, whatever. You get an instance, you put your app inside that, it works, awesome. And all the time your app grows, it's a bigger monolith. You decide to get another VM, you put another instance of the app there, load balance it, awesome. It works, but at the end of the day, it kind of gets out of control. And you decided to split it out into microservices. Okay, 3, awesome. And you keep it inside Docker containers. So in this case, you spin up 3 different VMs because, like, let's say this blue one is in Python, yellow is in Go, and green maybe in Rust. And you don't want to manage the entire dependencies and like libs and stuff. So you put it in 3 different VMs. Instead of that, you could have Dockerize this stuff. Again, since we have isolation of file system and stuff like that, we could probably put it inside one single container or one single instance, but 3 different containers. Okay, now let's say our need for this blue one increases and we need to spin up 3 instances of blue. If we are not having Kubernetes, we'll probably check this VM and see that there is no more space for another blue, spin up another VM and then put in 2 blue in there. But once Kubernetes comes in, okay, let's say we set this thing up, we plug it up to Kubernetes. And now what we can do is we could say, hey, Kubernetes, I don't need 3 instances of blue anymore. And it just drops down to 1. That's all you have to say. And it even removes that 1 extra VM that is not there. And yeah, you could say like, now make 5 copies of yellow. So what it does is it checks the first VM. There is no space in there. It creates another VM. It creates 2 yellow in there, and there is no more space in there. So it creates another VM and puts 2 more in there. So it scales. You don't have to take care of where to put the resources or should I spin up a new instance and stuff like that. And now you said put 2 more blue in there. Since there is already space in the existing VMs, you could just put in there. That's the idea of it. So Kubernetes takes care of the scaling aspect and resource allocation and stuff like that. Yeah, and when you have a client demo and you could do something like, hey, Kubernetes, scale it down. You don't need this. And that works. It's blissful. So the scaling piece, all of this can be automated. Right now, instead of saying, hey, Kubernetes, we need 2 more instances of this specific thing, or saying, I don't need this anymore, what you could say is, if there is request for this, just add more instances. Because not, just drop it down to 1. So like in your case, like in our case, for a lot of models, like for a month, we might not get a request. And sometimes we get like thousands of requests altogether. So it's easier to scale that way. Yeah, a small demo, but before that, cliche. Yeah, there is a lot of jargon going on. So a container, again, your Docker container. And now in Kubernetes world, a pod essentially is a container. The Kubernetes people, they don't want to call it a container. That's okay. And deployments, it's how you manage your pods or like deploy your pods into a VM. Service is, so you have your pods deployed or your apps deployed, and then you want to externally like let external things use this. That's what services are. Essentially load balancers. That's it. And nodes are VM instances and clusters, just a bunch Okay. Mm, so oh, better. Okay. So yeah. So this is a really simple Flask app. Okay. Yeah. A pretty simple Flask app. You have import Flask. You have a ping route. That's pretty much all you have to care about. And then you have an exit route, which if you call that route, it's just an exit route. Yeah, just to simulate some error happening, and then that's it. So you'll build this. That's with that you build this command. Again, this can be put into a CI/CD pipeline, which will again automate this piece as well. But let's say you're going to build, it's going to install dependencies and create a container which will contain the requirements, your base image. Uh, so this this is a Docker file essentially. So what you're doing is you start from Python 3.6. So what you're doing is you're getting a pre-built Python 3.6 image. This is an image published by the Python community. You pull that image in, you put your requirements in, you put your app in, and you start this thing. That's all you're doing. So, from Python 3.6, you copy over entire content of this source, like whatever directory you're working in, into /code. You move into the code directory, you install your requirements, and CMD or entry point is the way you describe how to start this app. Like when Kubernetes starts this app, it needs to know what to run, what command to run, and stuff like that. That's Python's overall UI. So yeah, once you build that, you could do this pushes it to Docker Hub. I'm not pushing it right now. I have already pushed this out, and okay, cool. So wait, okay. Okay. So in Kubernetes land, we end up writing YAML files for everything, pretty much. So as you said earlier, you have a deployment, and then you have a service. So deployment, you write a YAML file. Essentially, you like specify the kind, say that it's a deployment, and some metadata. Inside specs, you deploy, like you write the specs of the container that you're running or the code that you're running. So essentially, that is this is the image, and this is the container port that you're using. Flask as a default 5,000 ports. So that is this thing exactly. And with that, so you run that, you apply this YAML file, and if you see in the second window, that is actually that lists out the ports that are running. So it says that there is one port run, and same thing for yeah, same thing for service. Yeah, so it's service essentially, as I said, it's pretty much like a load balancer. So you say that connect to my demo app, and then map from internal 5,000 port to external 80 port. And essentially the same way you apply that, and then in a while you get a service running up top, and it does give it a while to give it and like assign it an external IP. That so on top, what you see is the services that are running. In this one, what you see is the ports that are running, and this will get to know in a while. So just waiting for it to get an external IP. So all this is running inside our cluster inside GCP. So when we say assign, like deploy this, make this deployment, like when I applied that deployment.yaml file, what it does that it said there is So yeah, the one on the right. So it says you need one replica. Just give me one replica of this spec which has this image, which is the one that we built and pushed. That's essentially what we're doing. And so when we run this, what it does is it creates a one instance of this pod in any of the VMs that we have in the cluster that we have assigned to this Kubernetes. And when we use this one on the left, it's you're saying create a load balancer and load balance the. So if you see, there is a selector thing. Selector is so selector and labels, they match up. So this one has a label of app demo, and that selector is picking up with that app demo label. So that's how it matches up the service and the deployment. So with this, you could have multiple services pointing to one deployment or multiple deployment using multiple services and stuff like that. I'm hoping we have an external IP. Okay. So if you were to ping that out, yeah, we get a pong. Awesome. It's simple. So we have deployed a container and a service and get response. That's awesome. Now to the fancier part. So this is just one instance of this pod running. So let's say I want to scale it up. Let's say I want to scale it up to 3 replicas. That's pretty much all you have to do, and it will create 2 other containers. It's just beautiful. It just scales out. And let's say you scale it up. So right now in this cluster we have 2 VMs. Let's say I want to scale it up like 20 or 30 replicas of that. It will spin up another container because there is no more space in this one VM. That's the idea. And again, to scale it back down, pretty much run that same command, and you're good to go. Terminating stuff. Okay, now to the automatic scaling piece. Yeah, so on top of a service, you write something called as a horizontal autopod scaler. This is another thingy that Kubernetes lets you do. So what this does is saying min replicas is 1 and max replicas is 3. So what that means is deploy this thing. If there is not a lot of traffic, just have one container. But if the traffic jumps, max it out to 3. Like you can create more containers, but like limited to 3. And we're scaling it based on the CPU utilization percentage. So if the CPU utilization gets over 30, you wouldn't put a value like 30, you'd put something like 60 or 70. But this is just for demo purposes so that I can actually show you scaling. Okay. So once should be applying. Okay, that did not work. Oh, okay. Okay, so instead of this curl, let's say I was gonna do this, which I'll explain what that is. So this is another utility. I don't know if you've used Apache Bench. This pretty much does something similar. So it's sending a total of 10,000 requests, but it sends like 100 requests at a time. So it actually gives the server something to scale based. That's it. So once you run this, if this actually works out, you can see pod scaling. Just give it a sec. Was supposed to scale ideally. Yeah, I was like I have this in a separate namespace, and HPS for some reason gets deployed to people namespace. Not sure what's happening.
what is the general response time for
Same as so like it depends. So depends on two things. First of all, if you have just one container and it's running, you should be investments. That's simple. And if it has to scale, what happens is you have to count in that boot time of the Docker container, which won't be that big, but same idea. Okay, for some reason this is not scaling. Okay, I'm gonna try that once more if that works out. Good applying.
Check the name.
Yeah, I have a sign. Okay. One sec. Okay, so I'm just trying to switch. Uh, Give it a while. So if you have any questions, I'll be happy to take.
Do you want to maybe talk about
Yeah.
fact that we use for machine learning models?
Yeah. So for model deployment, we have two main kind of deployments that we have set up. So one, again, something similar to what we see here is we have this pipeline set up where we have like, on a Git push that gets put over to cloud build setup, which automatically builds this container, pushes it over, and then does a similar kind of deployment and auto scale stuff. Again, same stuff. Every time a new version comes on to Git, this deployment happens and the scaling happens. In our workload, it's usually not a lot of model training for a while and then a bunch of model training. And another approach that we have is using jobs. So there are some models take a lot of time to train. That's okay. It's like even inference takes some time. So if you have a huge document going for any other stuff, it might take a while. So for that cases, we have another way to do it. As in, we might have used job queues for these kind of stuff. So what we do is we have okay, even in this one, there is this queue runner thingy. Oh, that's not getting so. Yeah. So this is one of our clusters that's running. So in this one, what happens is every time a job gets submitted, it gets into a Redis queue, and this KQ runner thing pulls it from Redis queue and starts a Kubernetes job, and that is scaled over multiple instances. So essentially, that's the idea. Right? If you want to talk more about it, feel free. Okay.
So essentially, all our models are deployed as REST endpoints or microservices. That's our structure that we follow. So whatever Abin is talking about Dockerizing it, like making available Kubernetes pods and stuff, right? That's pretty much what we follow. Model training does not happen this way. We do have some parts of model training. Like there's a virtual assistant framework called Dahlia that we use, where our business team, our product management team uses it live for model training and stuff. That actually still goes through the queue. That that's not a very complicated architecture or model per se. DPCN with Glove or maybe Bird for a little bit of things. So it trains rather fast. There's fine tuning aspects that we take care. But pretty much model training, we take take it offline, but inference is where this entire focus is on. This is the way we put things in production so that it scales. And our product is multi-tenant, right? A SaaS product is multi-tenant, so we need to worry about all these aspects of.
Okay. Unfortunately, this thing is not scaling. Something has gone wrong with my domain. So yeah, that's pretty much all I have, more or less. So yeah, if you have any questions, by the way, if you want the presentation is in that link. Yeah. That's it.
No question. Abin, either you did a really good job or people didn't understand what you're talking about.
Second one.
So this is really deploying your products in terms of enterprise level solutions.
Yeah.
So individual developers, how can we go about it?
Individual developers, to be frank, I wouldn't recommend using Kubernetes. Kubernetes actually, so another reason why we use Kubernetes is initially when we wanted everything we spin up stuff in there, and he started complaining about like VM costs. So that's when we initially went with the Kubernetes route.
It goes to my budget, right? I need to worry about this. VM costs are very expensive, and we in fact have integrated that with the Slack bot too. You could actually spin up things and spin down like using Slack bot. Like it's a DevOps pipeline that we worry about. Even though we are a research lab, experimentation happens in GCP, production grade deployment happens in AWS. We wanted to keep those two things separate. And even here, right, like when you actually expose things to product management or other things that actually use us to consume and do things, we wanted to make sure that it scales and they don't call us in the middle of the night. At least not me, right? We wanted to automate most of these pipelines. That's the reason for going towards something like this.
Yeah, so like individual developer don't.
Because true, but the point here is that I'm saying that it's that you have your own application.
Yeah.
And you're seeing that you're putting, say, for example, you have an app that you have put up and then the backend for some game of that subject.
Okay.
In that scenario, still a individual developer. It's a long
Yeah. Okay. It doesn't make a lot of big difference. Similar stuff. Minikube is like if you want to try stuff out, there is Minikube. So what it does is it spins up a VM inside your system and then. So initially, so this thing I was talking about in the beginning, right? These C groups and namespaces stuff. This is actually was only supported in Linux kernel. It's changing a bit. So in Mac and all, what they were doing was spinning up a Linux VM and inside that putting Kubernetes. You want to try stuff out. Docker, like putting Docker inside that. So individual developer or not, like Kubernetes, it's at the end of the day, you can get one instance of Kubernetes. Okay.
GCP is not that expensive though.
No, you could try it out on your personal VM, Minikube, or something like that.
And GCP is also not that expensive. You won't spend a lot of money spinning things up, right? For implementation, I would probably put in maybe $10.
Yeah, this thing. So
that's what you end up spending.
These guys actually give you a Kubernetes cluster for you to try stuff on. There's a time limit or something, but other than that, if you want to try stuff on, you can. Yeah. Yeah, that's pretty much it.
No questions. You want to see whether there's any questions in Zoom? I see some things come comment. See there.
Nope. Yeah.
No. Cool. Thanks. Abin. We'll maybe have a 5 minutes coffee break, by 10 minutes. The next speaker is getting ready to.